All right, let's take a look at GSR 1, the video dealing with the worksheet number 2. In this worksheet, or this particular area, deals mostly with dilations. And so we're going to look at a couple of questions dealing with dilations. The first is what does it mean to dilate? Well, basically to dilate something means to enlarge or reduce proportionally. So we're going to get things bigger or smaller, but it has to be proportionally. So in other words, the key there is the same shape. Things will get bigger or smaller based off of a proportional value. Now, where do we see this in the real world? Now, I'm no artist, but let me just quickly create probably the most common place we see a dilation is the eye. Oh, that's not so good at all. But anyways, watching the pupil get larger and smaller based off of light exposure. We see this all the time in imaging or changing pictures. We will often scale a picture down to something smaller, but we want to keep it proportional. We wouldn't want to create a picture that looks like, like something, very different proportion. This would make a very funny face, so we like the proportional look to it. What does it mean when we say we're going to enlarge something, or the dilation was an enlargement? That's the area where we say we're increasing proportionally. Okay, what does it mean to dilate? That means to decrease proportionally. Okay, so now we can look at some specific examples to determine if things are increasing or decreasing, if they're enlargements or reductions, I guess. So we'll look at some with diagrams, some with notation to kind of make sense of them. First of all, this says the scale factor is 5 to 2. Now the colon in mathematics represents division. So if you have a colon, you can just turn it into basically a fraction. 5 is to 2, and you know that that's 2.5. This would be an enlargement. So when we write a scale factor, it's the image to the pre-image. That way it will always convert to the scale factor. Whenever we write a scale factor, always write the image first and then the pre-image. The thing that we created and then the thing that we began with. And that will always help us to convert to the proper scale factor. So the scale factor here is 2.5. That's an enlargement. In this one, we notice that we have a smaller image than we do pre-image, so it got reduced. Here we see the k value. Sometimes k is used as our scale factor to be 5, so that's an enlargement. Actually, let me go back for just a second about k values. When we enlarge something, that means our scale factor is greater than 1. K is greater than 1. So 2 times bigger, 5 times bigger, 8 times bigger, that kind of thing. When we decrease things, k, the scale factor, will be between 0 and 1, like 1/2 the size, or 3/4 the size, or 1/8 the size. So these values are in this range here, and so they would be decrease or reductions. So let's finish these other ones. Notice that A prime is further away than the original. It got bigger, right? OA prime is greater than OA, so it got bigger, right? The image is bigger than the original. Here we're multiplying by 0.5. That, of course, is a reduction. Here our scale factor is 2/3. That is less than 1, and so we have ourselves a reduction. A couple other things, I guess, that I want to show you. Some examples of some good kinds of questions. This little number line actually turns out to be quite a bit of fun, challenging to do actually, but I want to go over it with you. So notice the center of dilation is T, so I'm going to just mark T a little bit here. And I'm going to take Y, which is 1 away, and multiply it, dilate it 3 times bigger. So always start from the center of dilation. 1, 2, 3. That would land us at P. So when you dilate, you don't start counting from the point, the Y point. You start counting from the center of dilation. So if we're going to do Y 3 times bigger, it would go 1, 2, 3 to get to P. Here, if we're centered at R now, if we're at R, this line's going to get a little messy. And F is way down here. That's F, and we're going to dilate it half of that. So F is 1, 2, 3, 4, 5, 6 away. So half of that would be 3 away. We would land, of course, at W. Let's dilate from P. Here's our P value, a total of 4, and it lands at R. So let's see where that is. Again, this is getting a little messy, but let's see what happens. So the end result landed at R. So what could we dilate 4 times bigger to get to R? I bet it's W, because W would be 1 away, 2, 3, 4. So yes, it would be 4 away. This is getting messy enough that I'm going to do a quick switch to do the other questions. Let's bring in a new sheet here and try the next one. So this says centered at H. Where's my H? Here it is. We're going to dilate K 3 times. Now K is 2 away. So 3 times would be another set of 2 and another set of 2. And so it would land at T. Alright, centered at T now. Here's our center. We're going to dilate M. So here's our M. Now we're going to dilate it negative 2 times. So that's going in the opposite direction 2 times. So there's negative 1, negative 2, lands at K. Finally, we're going to dilate from point F. Here we are at point F. And K is, where is K? K is right here. We're going to dilate, oh, we landed at K. So we got to dilate something 1/8 the size and land at K. So I bet you we got to go 8 times. 1, 2, 3, 4, 5, 6, 7, 8. It better be D, because if you take D and you dilate it 1/8 the size, it shrinks right down here to be this value. These are kind of tricky. It is good to maybe use your number line to help you to figure out what goes where. But they're doable if you have some patience with them. Let's take a look at some other ways that dilations get displayed here. Here's some original distances, 7, 8, and 6. They tell us that the scale factor is 3, and our center is O. So everything gets 3 times bigger. So I'm going to just put some things down that would help me make some decisions here. If this is 7, 3 times bigger is 21. Notice I'm not starting from B, it's from here 3 times bigger. So 7, 7, and 7. That would make this little distance here 14. If this is 6, then 3 times bigger makes this whole distance 18, making this little piece 12. If the distance from A to B is 8 and we multiply it 3 times bigger, it will be 24. And now I bet I can do most of these decisions. A prime, B prime, of course, is 24. And all I did is multiply 8 by 3 to get that, 8 by 3. O to B prime is 21, because that is also 7 times 3, 3 times bigger. O to A prime is 18, because that was 6 times 3. Now A to A prime, that's just this distance here. Notice it's the 12, because that is the remaining part of that total distance. That's 3 times bigger, 6 to here, 12 to here. So that was just 18 minus 6. And b to b prime is 14. Again, 21 minus the 7. What's the ratio between OA's distance and AA prime's distance? Well, it's 6 to 12, but reduces to 1 is to 2. The thing that most students get confused is they think that when they see like a 6 and a 12, they think that the scale factor of this diagram is 1 to 2. It's not. Remember, the scale factor here is 3 times bigger. This is just representing this little distance. 6 is to that distance 12. Okay, so just be careful in terms of keeping an eye on those things. Finally, let me just do this. One last problem like this. This time we're going to dilate by 1/2. This is going to be a reduction. And so you'll notice our AB here will get reduced down to something smaller. And in a likewise manner, I'm going to just fill out the chart first and then I'll go over here. But if you start with a distance of 8 and you dilate it by half of that would make this 4. Half of 6 would make this new distance 3. Half of 4 would make this distance 2. Let's see what else we can do. Well, let's go over here now and see if we got most of our answers. So a reduction would make this 2 because 1/2 times 4. O to B prime was 8 before, and half of 8 is 4. O to A prime is 3 because a half of 6. And then it asks for what was this distance. So it's just basically the 6 minus 3, and in this case is a 3. And this distance over here would be 8 minus 4, which happens to be 4. And then it asks for the ratio between OA to A prime and AA prime, which is 3 to 3, or in other words, a 1-to-1 ratio. These distances are a 1-to-1 ratio.